Hey everyone, welcome to our next video. For this one, we're doing 1.2, and I actually have the notes typed out for this one. It's because it's word problems. So if you go ahead and look at Canvas, here I'll go to it real quick. If you're on Canvas and you're looking at modules, you know, where we have all the videos and everything, it's 1.2 word problems typed. If you click that, this is the typed like questions. And then I'll just go ahead and go through the answers. All right. So we're starting with word problems. As you do the homework, there are some of these that maybe I didn't necessarily do an example similar to, but I think I think that some of them are pretty intuitive and I think you can figure it out. So just keep that in mind. So our first one we're starting off with, we've got Pat and Ron are planning to build a deck off the back of their house. The plans they found on the internet can be customized to the required deck height, which in this case is 92 inches. The plans, they call for posts of two different lengths. The taller one is 8 inches longer than the shorter one, and the plans say that the sum of the lengths should be the height of the deck. So how long should each support post be? So this is actually kind of a system of equations, which is something that we will do a bit later. Um, but we'll just get into it deeper later. Right now, it's just kind of a surface level. So we want to make two equations based on the information that it gives us. So right now, let's assign some variables. So I'll say X is the taller post, and I'll say Y is the shorter post. And you can make them whatever you want. If you do it backwards from this, that's fine. So it says the taller one is 8 inches longer than the shorter one. So if we write that as an equation, we're saying that x is equal to 8 plus y. Then for my other equation, it says that the sum of the lengths should be the height of the deck. So that means that x plus y should equal 92, which is the height of the deck. So in order to solve this, I really don't want x and y. Like I want an equation that just has one variable. So what I can do is I can take this one and replace it into for this x. So let's do that. So I'll get, instead of x, I'll put 8 plus y. And then I still have this plus y equals 92. So all I did was get rid of this x right here and write it as 8 plus y instead. Now we can solve this equation. So I have 8 plus 2y equals 92. To solve, I can subtract 8 from both sides. Come up here. I get 2y equals 84. And then I can divide by 2. So I get that y is equal to 42. And this is inches. Then to find my x, I'm going to use this equation again. So I know that x is equal to 8 plus y. Well, I just figured out y. So 8 plus 42. So this one's going to be 50 inches. And I'll go ahead and box these in. So technically, this is a system of equations using substitution, which is something that I would think that most people have seen at some point in high school. And we'll do harder ones of this kind of thing a bit later, but this is kind of a little bit of a sneak peek into it. Next up, we're going to do some distance equals rate times time problems. Let's see. I actually think that example 3 might be a little bit easier. So I want to do example 3 first. But we are still using this right here. Distance equals rate times time. So a girl participated in a 41-mile biathlon that included running and bicycling. She spent 1 hour and 45 minutes on the bike and 45 minutes running. If her average speed on the bike was 12 miles per hour faster than her average speed running, find her average speed running and her average speed riding. So as we go through this one, I'm going to make us a table to help like organize all of our stuff. So I have two kind of pieces happening. I've got her time running, and I've also have her time bicycling. And then at the top here, let me give myself a little bit more space there. At the top, I have the time that she was doing these things, and I have the rate that she was doing these. I'm also going to write distance. So basically what I'm doing here in my table is I'm using this equation of rate times time equals distance. So rate times time is equal to distance. But I'm just organizing all my information in a table. So let's see what we've got so far. I know that the total distance she goes is 41 miles, so I'll keep that in mind. So total distance equals 41. That won't actually end up in the table because I don't know the distance of just running or just bicycling. Let's see, I'm reading through now. She spent 1 hour and 45 minutes on the bike. Now, we don't want this in, you want it to be 1 unit. So if you look right here, you see how this is 12 miles per hour. That means we want to stay in hours. So we are going to have to do a little bit of converting here. An hour and 45 minutes can be written as 1.75 because 45 minutes is 75% of an hour. So 1.75. And then her 45 minutes running, we'll write that as 0.75. And again, the reason I'm doing this is because I don't want to be in minutes, I want to be in hours. So I'm just having to do a little bit of conversion there. Her average speed on the bicycle was 12 miles per hour faster than her average speed running. And we don't know her average speed running. So I'm going to call that X because I don't know it. But I do know that her bicycling was 12 faster than that. So I'll write it as X plus 12. And now from here, I'm going to fill out my distance. So rate times time equals distance. So for my running distance, I'll have 0.75x. For my bicycling distance, I'll have 1.75 times x plus 12. So now we have some stuff for the distance. I also know total distance. So I can add my two distances together and it should equal my total distance. So now I'm going to go ahead and make my equation. So I'm taking this stuff and this. So I have 0.75x plus 1.75 times x plus 12 is equal to 41. Okay. Now, when it comes to solving something like this, I know it has decimals, and I told y'all that I like to make these tests where they can be done with no calculator. This can be done with no calculator, but if you want to use a calculator for it, it's fine. I do try to pick ones on the test that don't use one though. So just keep that in mind as you do this one. If you wanted to do this one with no calculator, you could just multiply everything by 100. So if I multiply everything in here by 100, it'll get rid of all of my decimals. It's just then my numbers are kind of big, so you got to do a little bit of work there. But it's totally up to you. That's actually what I did in my notes because I like to not use the calculator. If you multiply all of this by 100, you get 75x plus 175 times x plus 12 equals 4100. And so again, those numbers are a little big, so if you want to work with the decimals and use a calculator, that's fine. But I want to prepare y'all that if you have to take maths after this, if you're engineering and science, you may not be able to use a calculator. Well, if you're engineering and science, you definitely can't use a calculator after this, but not all of you are engineering and science, so I have to keep that in mind. So now I'm going to go ahead and distribute here. So this gives me 75x plus 175x plus, and 175 times 12 is 2100. Put all my like terms together, so I'm going to subtract 2100 from both sides. Put my x's together, I get 250x equals 2000. And then if I divide both sides by 250, zeros cancel. I get x equals 8. So this means that her running rate is 8 miles per hour, and her bicycling rate, remember, is plus 12. And we got to be careful because they did ask for both of this. They said find her average speed running and her average speed riding. So we do want both. So that one is going to be 8 plus 12. So that one is 20 miles per hour. And I'll just box this in. Okay. Now I'm going to go to example 2. And I mean, you can decide for yourself if you really thought that one was easier than what I'm about to do, but I kind of thought it was maybe a little bit. So this one says Shelley drove 40 miles from Peoria, who knows if I'm saying that right, to Bloomington at 20 miles per hour. Then she drove back to Peoria at a higher rate of speed so that she averaged 30 miles per hour for the whole trip. What was her speed on the return trip? So again, I'm going to make a table. So I have 2 topics here. I have that we are, so that's where I'm going to put the rate, time, distance at the top. But I have that we're going, so we'll say P to B, then back to P, so we'll say B to P. Or if you want to put like her going trip and her return trip or something like that, just whatever makes sense to you to label. And then look here, because it says we have 30 miles per hour for the whole trip, we do want to have a row for the total. So just like the last one, I have my rate, time, and distance. And I'm going to put in everything that I know. So she drove 40 miles on her going trip. And then she drove back. So we can assume that these are the same distance because she's just going to a place and then back to her starting point. So this is going to be the same distance. On her going trip, she drove at 20 miles per hour. So I have this rate as 20 miles per hour. And on the way back, we don't know how much, we don't know how fast she drove. And it does ask us how fast she drove, so we're going to go ahead and call that X. It also says that she averaged 30 miles per hour for the whole trip. So for the total, I'm going to put 30 miles per hour. Now, I don't have any information about time. It just didn't tell me anything. But I do know how much of the total distance she drove because the distance, if I add them together, she drove 80 miles altogether. Now, the reason I thought this one was a little harder is because for the time, you have to actually solve for it a little bit. So if rate times time equals distance, then time equals distance divided by your rate. So in my time column, I'm going to have to use my rate and my distance to find that. So here I get 40 divided by 20, so that's 2. And this is in hours. For my return trip, I have 40 divided by x, and I can't simplify that at all, so I'll just leave it as is. And then for my last part here, I'm going to go ahead and add my times together. So if I add my times together, that should equal my total time. So that's going to be 2 plus 40 over x. Now I'm going to use my distance, sorry, not my distance, my total equation here to go ahead and write an equation, and then that's what we're going to solve. So remember, it's rate times time is equal to distance. So that's what I'm going to write out. So I have 30 times 2 plus 40 over x is equal to 80. And I need to solve this for x. So I'll distribute. I get 60 plus 1,200 divided by x equals 80. Always remember, if you want to get rid of your denominators, go ahead and multiply by them. So I'm going to multiply everything by x. That gives me 60x plus 1200 equals 80x. The x, the two, sorry, getting a little tongue twisted. The 1200x over x, the x's cancel, so that's why I'm just left with 1200. I'll move my 60x over. So this gives me 1200 equals 20x. And then I can divide by 20, which gives me 60 equals x. And that is all we were looking for, because it said, what is the speed on her return trip? And that's just x. So we were just looking for x for this one. So I'll just box that in. Just be careful. Sometimes you may be asked to find something else, kind of like with example 3, how we were asked to find the running and the bicycling rates. So just watch out in case maybe there's another part of the question. Now, word problems can always be a bit tricky, so please let me know if you are having issues with these. I'm sure sometimes there's different ways to solve them as well, so that's something to keep in mind. For instance, I was thinking like, oh, what if I, instead of right here, what if I had written 80 over 30? Well, then my equation may have changed, but I still would have ended up with adding the times equal to the total time. So it has still been 2 plus 40 over x, except on the other side here, I would have had 80 over 30. So sometimes you could set it up a little bit differently, but your equation should end up roughly the same. All right, I'm going to move on from these. That's it for the rate and time and distance problems. Next, we're going to do some perimeter, and this one is actually probably more like example 1. So for perimeter, remember that you just add up all the sides. And I think there's one in here that talks about like perimeter and area. I can't totally remember, but I think you guys can do it. Example 4, so Pam is planting a garden, and the length of the rectangular garden is 40 feet longer than 3 times the width. The perimeter is 640 feet. What are the dimensions of this garden? So right here, since it's a rectangular garden, I know that I have 2 widths and I have 2 lengths. Be careful, sometimes maybe you don't have one of the lengths or one of the widths. Like a good example of that is if you ever see one that's like a door problem, you don't need, like they'll say something about like molding around a door, and you don't need molding at the bottom. So that's only like a 3-sided rectangular shape. So just be careful about how many sides you actually have. And then it says, so the length of the garden is 40 feet longer than 3 times the width. So the length is 40 longer than 3 times the width. So I made that into an equation. And then it talks about perimeter here. Well, I know that perimeter is length plus width plus width plus width. And it says that the perimeter is 640. So that means P should be equal to 640. And then I also know that L is equal to 40 plus 3W. So I'm going to replace that. So I'm replacing both of my L's here, and then I still have my widths. I'm going to combine all my like terms. I'll give you a little thing here. You could have also written this as 2L plus 2W, and then maybe you'd have just distributed. Again, the work may look a little different depending on what you choose to do. 80 plus 6W plus 2W. So let me add those together. So I get 80 plus 8W. Subtract 80 because I'm trying to solve for W. That gives me 560 equals 8W. Divide by 8. And I get W is equal to 70. So my width is 70. Now if I want to find my length, remember that length is 40 plus 3W. So I can plug that in. I get 40 plus 21, 210. So this is going to give me 250 for my length. So I'm going to write this a little bit nicer. So I'm just going to say that my length is equal to 250. And this is feet. And my width is equal to 70 feet. I'm not a big, I'm not really strict about writing the units on there, but it is good to keep in mind. So that one was kind of like example 1 because we substituted that L in there. So it's kind of like a little bit of a system of equations problem. Example 5, I'm actually going to come back to using the table. So I would use this method anytime you're dealing with percents. Or like money could be used for this one, like this kind of idea that we're going to do. So let me go through the problem first. A beverage producer makes 2 products, an orange drink containing 10% orange juice and Orange Delight containing 50% orange juice. How many gallons of Orange Delight must be mixed with 300 gallons of orange drink to create a new product that contains 40% orange juice? So we've got 2 drinks happening here. I've got the orange drink and I've got the Orange Delight. So I'm just going to write drink and delight. And then it says that we're like mixing these together, right? Because we're creating a new product. So I'm going to just say the mix of these. Now at the top, I have my percentage of orange juice. I have the amount of the drink that we're dealing with. And it's very similar to the rate and distance. We're going to multiply these together to get something else. If you multiply the percentage of something by the amount that's actually in the drink, we'll get the amount of the orange juice, right? Because if I have, like, let's say it's 10% orange juice and I do 10 gallons, so if I multiply 10% times the 10 gallons, that's 1 gallon of orange juice. Also, I want us to be careful here. Whenever you are working with percentages and you're like putting them in equations, you should always change them to decimals. So percentage should be in decimals. So for my percent of orange juice in the orange drink, that's 10%, so that's going to be 0.1. The percentage of orange juice in the delight is 50%, so that's going to be 0.5. The percentage of if orange juice in the orange drink is 40%, so that's 0.4. Now let's look at my amount of like liquid. So let's see, it says how many gallons of the orange delight have to be mixed with 300 gallons of orange drink. So I know that the orange drink is 300 gallons. I don't know how much orange delight, so let's go ahead and call that X. So if I put these together, this is going to be 300 plus X. And so then the amount of my orange juice, I'll go ahead and multiply across. So I multiply these to equal the amount of orange juice. So this is 0.1 times 300, 0.5 times X, 0.4 times 300 plus X. So I just multiplied across. Now, much like with the distance problems, I can add these two together to equal the third row. So if I add together how much OJ is in the drink and the delight, I'll get how much is in the mix. So I get 0.1 times 300 plus 0.5x is equal to 0.4 300 plus x. Now again, working with the decimals might be a little difficult, so just be careful there. If you multiply everything by 10, you can get rid of the decimals. So I'm going to do that. I'm going to multiply by 10. This will give me 1 times 300 plus 5x equals 4 times 300 plus x. I'm just going to continue solving this. So 300 plus 5x equals 1200 plus 4x. Combine like terms, so I get x equals, subtract the 300, that gives me 900 gallons. So that's how many gallons of the orange delight I need to use. I tend to like the mixture problem, so keep that in mind. Our last question here, I'll go this one a little quickly. It's just a proportions problem. So it says there are 8 more men than women in this jury pool. Sorry, there's a little typo there. And it says the ratio of men to women is 8 to 7. So men to women, the ratio is 8 to 7. Also, I know that I can call, like, so I can say a variable. So I can say if X is the number of women, then X plus 8 is the number of men. So if I set up this proportion, I have number of men at the top, so that's going to be x plus 8. And I have number of women at the bottom, which is just x. To solve this, you can multiply each side by the denominators, or you can think of it as cross multiplying. And you get 8x equals 7 times x plus 8. Distribute. Finish solving. I move over that 7x. I get x equals 56. So there's 56 women. And for men, there's 8 more. So 56 plus 8 is going to be 64. I'll put a note here. I'll say 56 plus 8. So that's 64. So I know I went through that one pretty quickly, but it's just proportions, which is something that I would have expected you guys to see already. Now, as always, if you have any questions about anything we went over, please let me know. Send me an email. We can always make an appointment. I hope you all have a wonderful day. Bye-bye.